In this video, we need to talk about the idea of calorimetry. It's related to something called specific heat, okay? Specific heat is a constant for any given metal. It is not actually heat, which is super confusing. It's also abbreviated as a capital C. I've never figured out why they thought that was a good idea either, but that's what it is. It's essentially a measure of how easily a material absorbs and releases heat. You guys probably have firsthand experience with this. Metals tend to have very low specific heats, which means they absorb heat very easily. This is why most of your cookware at home is made out of metal, okay? Whereas things like water has a reasonably high specific heat, which means it takes a lot of energy to heat it up. This is why if you're ever making pasta or making mac and cheese or something, like you put your pot of water on, assuming I'm not talking about microwave stuff, but if you're on the stove and you have a pot of water and you need it to heat up to cook your pasta, it feels like it takes forever for that water to get warm. And the logic is that basically it does, because water is very, very good at resisting temperature changes. It is bad at absorbing heat. That's not necessarily a problem, it's just everything absorbs and releases heat a little bit differently. And there is an equation to relate all this stuff. So a little bit of algebra here, sorry. The equation looks like this. Q equals mc delta T. Okay, so we need to define a few things. Q is the energy. It's basically the heat that's being gained or lost. Again, specific heat is not actually heat. It's a measure of how well something absorbs or releases heat. Okay, so its units are going to be joules. Okay, M is the mass. We're going to put that in grams. Mass is important in this because honestly, the more material you have, the longer it's going to take the harder it's going to be for it to absorb energy. So in other words, if you had, 1 gram of iron and you had to heat it up, it wouldn't take very much heat. If you had 100 grams of iron, it's going to take significantly more heat to raise its temperature. So again, not a big deal, but this is why mass is important. C is literally the thing we just defined. Its units are a little weird, so I guess I'll label it down here again just in case. It's a constant, and its main job is to cancel out everything else. So I'll label this real fast. Delta T together is one thing, and it stands for change in temperature. We, by default, do all this in degrees Celsius, because science, I guess. So in order for the units to cancel out here, specific heat's units have to be joules per grams degrees Celsius. So joules is on top, and grams times degrees Celsius is on the bottom, which is a little messy, but its only job is to cancel out everything else. Okay. Honestly, these problems really aren't that tough. Basically, you'll have 3 of the 4 variables. You just have to solve for the one you don't know. Sometimes people struggle with the algebra, but I can try to help with some of that too. Okay. So, yeah, let's just try an example. So how much heat in joules, J is joules, does it take to raise 225 grams of water from 30.0 degrees Celsius, which is a little over the body temperature, to 100. Say we're boiling it. Okay. The specific heat of water is equal to 4.184 joules per grams degrees Celsius. Okay, so this is our problem. And what we need to do is use this equation, which I'll rewrite down here so you can see it, Q equals mc delta T. Okay, so what I like to do, honestly, is just do an inventory of what we have to find. We have Q, M, C, and T, or delta T. Okay, we just need to see what we do and don't have. Okay, so looking from top to bottom, the mass is 225 grams. C is 4.184 joules per grams degrees Celsius. And delta T is the change in temperature. So you take the bigger one minus, basically just make it positive. It went from 100 degrees to 30 degrees, so the difference is 70 degrees Celsius. And Q is how much heat it's going to take. We're heating up water, so this is what we're solving for. So in this particular case, we don't have to rearrange the equation. Okay, it's already solved for Q. So we just plug all the numbers in. 225 grams times 4.184 joules per grams degrees Celsius times 70.0 degrees Celsius. Your grams are going to cancel out, your degrees Celsius are going to cancel out, and you'll be left with joules, which is super useful because we're solving for an energy value. Joules are a very small unit, so 225 times 4.184 times 70. I'm hitting the wrong numbers. 70. And I got a really big number. Okay. So 6, 5, I guess this has 3 sig figs, this has 4, this has 3. So 6, 5, 8, 9, 8 joules, but we have to round it there. So the answer is 65,900 joules. This is the same thing as 65.9 kilojoules. Okay. Let's try another example, one where we have to rearrange the equation a little bit. Okay. I'll just make one up, I guess. Okay, so some example. If a sample of iron absorbs, I don't know, 1.43 kilojoules of heat, and the temperature increases from, I don't know, 10.0 degrees Celsius to 56.4 degrees Celsius. We want to know, what is the mass? We need the specific heat of iron, which is 0.45 joules per grams degrees Celsius. Okay, so we need to do the same inventory thing, Q, M, C, and delta T, and see what we're solving for. Q is the amount of energy in the form of heat, so 1.43 kilojoules. M is what we're solving for, it says what is the mass. C is 0.45. You'll notice that iron has a significantly lower value than water, which is why your iron pans heat up a lot faster than water does. Joules per grams degrees Celsius. And delta T is the difference in temperature. So 56.4 minus 10 would be 46.4. Okay, I will tell you that joules per grams degrees Celsius, the units for specific heat, are going to determine what all the other units need to be. I know a lot of my physics students, my pre-engineering students are really bad about not checking their units. You need to make sure they cancel out. This is kilojoules, this is joules, something's got to change. So, turns out that 1 kilojoule is 1,000 joules, so cancel out kilojoules and get joules. So the answer is 1,430 joules. Okay, let's do a little bit of algebra here. Q equals mc delta T. We need to solve for m. Okay, I'm going to show all my work because I have a lot of students who seem to struggle with algebra here. So what we need is m by itself, and we need everything else to go away. So we need c and delta t to vanish. So since C is up here, we're going to divide by C on both sides. Whatever you do on one side, you have to do on the other. Then you have to divide by delta t to get rid of this. And I'm going to divide by delta t over here. So I'm going to rewrite this so it's a little prettier, but this side is entirely m. This side is q over c delta t. So we have all those variables, we just plug them in. So this is 1430 joules divided by 0.45 joules per grams degrees Celsius. And the temperature is 46.4 degrees Celsius. Okay, our degrees Celsius cancel out, our joules cancel out, and we have 1 over Celsius, or sorry, 1 over grams. So the inverse of the inverse gets you grams. So m is whatever that number comes out to. Okay. So we take 1430 divided by 0.45, it equals, divided by 46.4. I got an answer of, I guess, 3 sig figs. This only has 2. The answer is 68 grams. 68.4, so we'd round down. Okay, so a little bit of algebra in here, but otherwise these problems aren't too bad. Usually there's 4 variables. You have to have 3 of the 4 or you can't do the problems. So, all right, thank you.